In this problem, we have a Van de Graaff generator that has a positive charge. Remember, the way we've looked at it, it's kind of sucking electrons out of the dome. And it has this charge buildup that's positive, which can be neutralized by Mr. Werman touching it, right, and giving electrons to it. So that effectively cancels out that positive charge by adding electrons to the dome. Well, if that's the case, electrons each have mass, so how much mass is added to the dome? We've seen this problem before. Let's set it up. I have 6 millicoulombs of charge, and we have conversions from charge to electrons and electrons to mass. So we're effectively trying to take millicoulombs to coulombs, coulombs to the number of electrons, and the number of electrons to some corresponding amount of mass. And that would give us the answer that we're looking for. So I start with my value. Again, signs aren't that important in this case. I'm going to get rid of millicoulombs and go to coulombs. My conversion from milli, 10 to the negative 3, is the same as milli. So I can get rid of millicoulombs. I want to get rid of coulombs and go to number of electrons. I can use either one of those conversion factors. Let's keep the stuff out of the denominator. So I'll use the 6.25 times 10 to the 18 electrons in 1 coulomb. And then lastly, we'll go from electrons to kilograms. Again, I'm just algebraically canceling these, they're kind of like units, right? And so the mass of 1 electron is 9.11 times 10 to the negative 31 kilograms. And so before I do any calculations, I'm going to check millicoulombs, millicoulombs. All right, that makes sense. Coulombs and coulombs cancels. I'm now in electrons, and electrons and electrons cancel. I'm in kilograms. And all my denominators are 1, so now it's just a matter of going into my calculator and carefully plugging in 6 times 10 to the negative 3. Well, that's just second e to the negative 3. Again, we could have done that in a step without a fence post if we knew our trick. Times 6.25, second e to the 18, times 9.11, second e to the negative 31. I'm expecting a very little amount of mass. Let's check. I typed it in right, and I think you get 3.42 times 10 to the negative 14 as my answer. 3.42 times 10 to the negative 14 kilograms of mass. So that's the amount of mass in electrons that are added to that dome to neutralize it.